225 million kilometers. That is the average distance between where you are standing right now and the surface of another world. We know Mars better than any of our ancestors knew their own continent. And the more we learn, the more it unsettles us. 4 billion years ago, Mars was not the world we see today. It had a hydrosphere, a full, functioning water cycle. Rivers carved channels into basalt. Oceans sat quiet under a sky thick with nitrogen and carbon dioxide, with enough pressure to keep liquid water stable on the surface. Rain fell. The Valles Marineris, a canyon system 4 times deeper than the Grand Canyon and long enough to stretch across the entire United States, was not carved by wind. It was shaped by tectonic forces and ancient floods of a scale Earth has never witnessed. Olympus Mons, the largest volcano in the solar system, was actively erupting. A mountain so vast, it has its own weather system at its peak. Its base so wide that standing at its edge, you would not be able to see the summit. The curvature of Mars itself would hide it. This was not a barren rock. This was a living, geologically active, potentially habitable world. And then, something fundamental broke. Inside every planet with a magnetic field, there is motion. Liquid metal rotating, convecting, generating an electromagnetic shield that stretches thousands of kilometers into space. Approximately 4.2 billion years ago, the Martian core cooled faster than models predicted. The convective engine that powered its magnetic field stalled, and without that shield, Mars was exposed. The solar wind, a constant stream of charged particles ejected by the sun at hundreds of kilometers per second, began doing what it always does to unprotected worlds. It ionized the upper atmosphere. It stripped molecules one by one and flung them into space. NASA's MAVEN spacecraft, which has been orbiting Mars since 2014, measured this process in real time. Even today, the solar wind removes approximately 100 grams of Martian atmosphere every second for 4 billion years. Do the math. What remains today is less than 1% of the atmospheric pressure we breathe on Earth. Standing on Mars in a pressure suit, because without one you would lose consciousness in seconds, would be a study in extremes. The sky would not be blue. Suspended iron oxide particles scatter sunlight differently than nitrogen and oxygen. The sky is a pale butterscotch at noon, fading to deep violet and blue near the horizon at sunrise and sunset. The opposite of Earth. Sound travels differently here. The atmosphere is so thin, 95% carbon dioxide, 2.6% nitrogen, trace amounts of argon and oxygen, that sound propagates at a different speed than on Earth. Mars has a voice. It just speaks very, very quietly. On Earth, our magnetic field and atmosphere absorb and deflect the vast majority of cosmic rays and solar energetic particles before they reach the surface. On Mars, those particles arrive nearly unimpeded. Any permanent human presence on Mars would require living underground. Inside lava tubes, ancient volcanic channels that stretch for hundreds of kilometers beneath the surface, not as a temporary measure, as a permanent way of life. The surface of Mars is not a frontier to be settled. It is an environment to be survived. In the summer of 2018, a dust storm formed in the Perseverance Valley region of Mars. It did not stop. Within 2 weeks, It had grown to encompass the entire planet. For 3 months, the sun was obscured. Solar irradiance at the surface dropped by 97%. The Opportunity rover, which had been operating for 14 years, 11 years beyond its original planned mission, sent its final transmission on June 10, 2018.
NASA's Curiosity rover captured these images as the dust rolled in, obscuring the horizon. Also in the storm's path was NASA's InSight lander, which had to stop its science work after dust prevented sunlight from reaching the solar panels. InSight hunkered down for 11 days to conserve battery power, but didn't weather the storm alone.
Opportunity never responded. There are currently active spacecraft in and around Mars, and there are others that are no longer active, frozen in place, dusted over, silent. Opportunity sits on the inner slope of Perseverance Valley, facing east, the direction of the rising sun, as if it fell asleep mid-stride. Ingenuity, the small helicopter that was supposed to fly 5 times, completed 72 flights before a rotor blade was damaged on landing. Its final resting place is in Jezero Crater, less than half a kilometer from Perseverance. We do not grieve machines, but we designed them to be curious. We built them in our image, and they went to a place we could not go and did everything we asked of them, and more. That means something. We have not found life on Mars. Let us be precise about that. But we have found organics. We have found ancient habitable environments. We have found evidence that liquid water existed for millions, possibly hundreds of millions, of years. The question of whether something ever lived in that ancient ocean, in those hydrothermal vents, in the thin subsurface water that may still exist today. That question is not settled. It may be the most important, unanswered question in the history of science. Either answer changes everything. It is not a slow degradation. On geological timescales, the loss of the Martian atmosphere was rapid. A world that had rivers and rainfall became a frozen desert in, geologically speaking, the blink of an eye. We live on a planet that has maintained habitable surface conditions for approximately 3.8 billion years. That is not guaranteed. It is not permanent. It is the result of a specific set of circumstances. A large moon stabilizing our axial tilt, a magnetic field generated by a still active core, an atmosphere carefully balanced by biogeochemical cycles that we are only beginning to understand. Mars is not a warning about our future. Mars is the data. The last molecules of its ancient sky still drifting away at 100 grams per second. The last traces of its water locked in ice and mineral hydration. With our rovers and our orbiters, and our plans and our ambitions, we are listening to it exhale. And if we are wise, not just scientifically, but philosophically, we will understand what that means for the world we came from. Mars did not fail. Mars did not choose this. It simply ran out of the internal heat that kept its magnetic heart beating. It ran out of time. Earth has not run out of time. Not yet. But we have learned from billions of kilometers of evidence that habitability is not a default state. It is an achievement. It is a balance that can be broken. We go to Mars to understand it. We should come home to protect what we have.